Okay, before we start the next lesson in this chapter, again, a couple of warm-up questions based on multi-step equations from our last lesson. So pause the video and work these two problems out. We'll be back together. Okay, let's take a look at the solutions for this first one. So for the 7x plus 14 minus 3x equals 30, you should get a solution of 4. And in the second one, you should be getting a solution of negative 3. Okay, moving on to today's work, which is going to be solving equations with variables on both sides of the equal sign. So objectives. We're going to practice solving those types of equations, and we want to make sure and identify equations that are identities or have no solutions. We'll talk more about that as we get into this lesson. Let's just start it off. Again, there's really no new skills for this section, so the best thing to start is just work on some examples, get some practice. Okay, so if we look at this first one, on the left, you'll notice we have 5s plus 13. On the right, we have a 2s plus 22. So sometimes the challenge to these is that I have a variable on both sides, and I have a constant on both sides. Don't let that scare you, okay? The steps, the tools are exactly the same, and I'm going to give you a couple hints. The first one being, when you go to move any of these numbers around, I always try to choose the smallest number. So if I'm moving constants, the positive 13 is less than 22. That's a good place to start. It's not the only place. If you want to start with the variables, notice that the coefficient 2 is smaller than the 5. That's another good place to start. The reason those are good places to start is it helps keep me from having to use negative constants or negative variable terms. Okay, and it seems like whenever I can avoid that, I have a better opportunity of getting my answers correct without the confusion. So I like to start with variable. So when I subtract that, we end up with 3s plus 13 equals 22. And we're quickly down to a two-step equation now. Okay, the rest of this is no different than some of our previous lessons. So get rid of the 13, and finally divide by 3 to eliminate the coefficient here. We'll be multiplying the s by 3, and you end up with s being 3. Okay, now you notice here I put make sure you check your work. As these start getting bigger, it is a good idea to go back, take your solution, and go to the very beginning and substitute that value in for your variable. And notice that both sides, the left and the right, when you do that, should be equal. Okay? So if I did that, we would end up with 5 times 3 plus 13. On the left, we want it to be equal to 2 times 3 plus 22 on the right. Here we have 15 plus 13 and 6 plus 22, and both sides we have 28. Yes, it takes some more work. I agree. But those of you that are focusing on, being an A student, making sure you understand it, maybe even a B student, you're going to take the time to go do this, okay? It's worth your time. All right, let's go on to another one here. Ah, yes, a word problem that we all love. Okay, let's find a way that we can apply our tools here. So Laurel pays somebody $35 to clear her driveway when it snows. However, she wants to buy an electric snowblower for $689 so she could just do it herself. Okay, if the place where she lives has an average snowfall or an average of 5.2 snowfalls each season, how many seasons will it take her to break even on what she spent for the snowblower? All right. So now this doesn't go into and talk about some of the other things we could say is, what if it's ice, how many inches of snow and stuff. So we're really simplifying this, and I understand that. So we know that $35 for every snowfall. So there's 5.2. This is going to be the total amount she spends every season. So it looks like she spends $182 per season. So how many seasons will it take her to pay off or break even on that snowblower? Well, the snowblower costs $689. So if we divide it by the amount spent every season, right, total cost divided by the per season cost, we know that it's going to take approximately 3.8 seasons, almost 4, to break even. Okay? So just a little example of some of the things we've been working on and how we can use them in a real situation. This is something that, as adults, we would all kind of think about. Is it worthwhile buying the snowblower? Okay. Okay. Example 3. Let's try to do one that has grouping symbols. Okay, and we have variables on both sides again. So your first step is go ahead, apply that distributive property to both sides now. You guys should be getting pretty good with that. Just remember, the key errors that are made is a lot of times we forget to multiply the second number, right? Or we miss the sign when we're multiplying. So when I do that, right, if I apply the 2 using multiplication to both sides or both terms, 6x plus 2, then on the right we get 4x, and it's a minus 20, right? 4 times a negative 5 minus 20. Now, like I said, I like moving the variables to one side right away. You don't have to. There are 4 different things you could do to start this problem. Okay? I'm going to move the 4x. Again, it's the smaller coefficient. I've got a better chance of keeping positive values. When I do that, we end up with 2x plus 2 equals a negative 20. Let's move the constant now. Let's move this constant right here. How do I make it go to 0? Well, we're going to subtract 2 from both sides. And that moves my constant to the right. I end up with 2x equals a negative 22. And I divide both sides by 2 to get x equals negative 11. Okay, and once again, take the time, take your answer, your solution, back up to the top, and substitute it in and see if both sides end up being equal. If they are, then you're good. Okay, both sides are equal, check them off. That's what we want. Okay, there's something we need to pay attention to here, and that's equations with no solutions, right, or identities. So in here, I've put some information. An equation that is true for every possible value of the variable is an identity, or you may have heard it as infinitely many solutions. It's when both sides are the same. 2 equals 2, x equals x, 4x equals 4x, something like that, okay? However, an equation that has no solution, that means there's no value for a variable that will make it true. Okay, now these sometimes look like where you have 2 different numbers. 2 equal to 6. Well, that's not possible. Okay, that means that there is no solution in that equation. So let's try one. What is the solution here, okay, of our equation? Well, first we're going to combine the like terms on the right-hand side. Right here, again, notice I'm circling the signs with them. Oh, wrong way. Let's go back here forward. So we have t plus 8 equals t plus 6. So if I move the variables to the same side, notice what happens. Well, I end up with no variable at all, but I have 2 numbers, and you and I both know that 8 cannot be equal to 6. Therefore, we have no solution. Okay, let's try another one. Go ahead and pause the video, work through this, and I'll come back and I'll show you what the answer is, and we'll see if it matches. Okay, let's see what we get here. Huh, look at that. Now this time, when we went through and got our solution. Again, the variable goes away. However, we have 6 equals to 6. That's true. You can have that. 6 does equal 6. So we call this an infinitely many solutions, or the identity. Okay. All right. Good work today on this lesson. Make sure you jot down the questions that you have, bring them to class, and we can go through them as a class, or we can go through them individually if you want. But I'm sure that everybody's got a few questions on these as we go through them. We'll talk about them tomorrow.